Hello, this is me Aniq Ahmad, and I am presenting a poster on interactive seismic facies segmentation using multi-attribute seismic data. And the main aim of this presentation is to make the sustainable use of AI into our geoscience workflows. So we are working a little bit different from the traditional machine learning and deep learning models that are acting as a replacement to geoscientists, but we are working on a thing that we want those models to be assistant to the geologist or a geophysicist. So with this thing said, we took a challenge. That's a seismic interpretation. That's often we know that it's a iterative process that takes time and is often subjected to the interpreter biasness. So every interpreter has its own interpretation. So we took this challenge and we adopted a model that's a pre-trained by Meta AIs that segment anything. So what this model does, it takes prompts from the users. So we wanted to have the geologist or a geoscientist to give prompts to it, and then it works for you. So we took this model and then we followed two approaches. We followed a traditional approach, that's the fine tuning of that model, that in which we took different attributes and then we fine tuned our model to perform a specific task. But then we realized that this fine tuning made the model very specific to that particular task. For example, if you are segmenting or if you are classifying a certain feature, let's say salt. So this fine tuning will make the models to that specific segmentation of the salt or a karst, we can say. So, but we wanted to have a generalized model that will segment not all but almost every geological feature. So what we did, so these are the initial results that what we got with the fine tuning. We took seismic with the mask to train our model. Then we took different attributes, amplitude, as a signals, coherence, and curvature, and we fine tuned our model for the salt and the karst bodies. And these were the results that we got with our fine tuning model. So these were our ground truth, and this was the base model that wasn't fine tuned, and this was our fine tuned model. And we can see that this box is actually a user prompt that this model takes from the users. So we can see that a box around these karst features, we can see it's segmented good, and also for the salt body as well as compared to this ground mass. But that thing made model very specific to these karst and salts. So what we wanted to have more generalized model that works for all features. So then we moved to our more exploratory analysis, and then we took different data sets for channels, for salt, for different conformal sediments, and then we worked on enhanced inputs rather than fine-tuning the model. So we wanted to have the model as it is in its original position or its original state, we can say, and then we worked on our inputs to be more strong for the model to generalize. So what we did, we incorporate different types of prompts, and those prompts are actually the point prompts and the mask prompts. So mask prompts are actually the prediction from the previous iteration. So what we found that if you just take the model as it is, and if you just provide it the point prompts and the mask prompt, you get a very good segmentation. For example, let's see, these are the salt features, salt diapers, we can say, and we can see that this model has segmented in a high accuracy these salt bodies. And these red points actually show that the areas that we don't want to include, and the green shows the areas that we want to segment. So this was for the salt data set. We also explored for the conformal sediments, and we can see that we don't need to fine tune or retrain the whole model. We just need to provide good prompts to it, and it can segment it for you as well. And also for the channels, we can see that it has segmented two very small channels here with the number of prompts. So this was using the prompting technology. Then we incorporated our domain aware knowledge, that we say the seismic attributes, into this model, and that's something that is lagging in the traditional machine learning or artificial intelligence network. So what we did, we calculated different attributes, multispectral coherence. So the top two are the results of the multispectral coherence, and here we can see small tiny channels. And when we provided this input to the model and we provided the prompts, and it segmented those channels in a very good accuracy. We can see, although it required more prompts, but still it has segmented very small channel bodies as well. So this was the result with the multispectral coherence, and this is a band limited coherence. I think this was on 30 hertz and this was on the 50 hertz. So we can see that the channel bodies are segmented here, are in a good shape. So these were the results that we got without retraining the whole model for a specific task. So our aim to have more generalization, to have more feature segmented with the base model was we were in the right direction. We also tried different data blending techniques. We can see here I blended seismic and two attributes, and we got a very good accuracy with the segmentation. And then we also tried different color rendering techniques as well. As we know that the seismic data is highly, when you see data from different angles, you see different features. So what we tried to apply color renderings to the seismic data. For example, the bottom one is the seismic color rendering. That's a typical one. We tried the model on this one. We also tried the model on the grayscale datasets, and we tried the model on the raw dataset. And we have explored that this model, segment anything, performs very good if you take the raw datasets rather than when you apply the color renderings. It might be possible with the color renderings you might expect more channel bodies or more complex feature to segment, but for the conformal sediments we have analyzed that if you take the raw amplitudes, just stack them together, use this model, it will segment in a good condition. So this was our whole research, and here I'm discussing the observation that we have analyzed so far. So we have tested different feature, karst, salt, channels, conformal sediments, and various facies, and we have analyzed that this model reduced the manual interpretation. It doesn't need any fine tuning. It doesn't need any of your computer resources or the complex time or large amount of time that we need to retrain the model. You just need to integrate this model and just start doing your work.